On the bench today, we've got the MXR micro amp, and we're going to use that to look at clean boost headroom. What is headroom? In my mind, headroom is the ability of an amplifier or a gain stage to amplify the signal without creating distortion. And this is the same whether it's a preamp stage, a power amp stage, or even a gain stage in a pedal. So let's have a look at our MXR pedal, and we've got the gain set to maximum, and we have a beautiful clean 1 kHz sine wave on the oscilloscope. The amplitude going into the pedal is 100 millivolts or 0.1 of a volt, typical of, say, a single coil Strat kind of pickup. And now we're going to turn up the amplitude, so to 200, and there you go. We've just doubled the voltage from 100 to 200 millivolts, and the sine wave is no longer a beautiful sine wave. It's clipped. The tops and the bottom have been chopped off, and what that means is we're creating a lot of harmonic components and it's distorting. So the clean headroom when the gain is set full on an MXR microamp is pretty poor. I mean, we can turn it down. Let's just turn it down to, say, there. Let's just go to 3/4. And then turn up the amplitude some more. And there, it clips there at about 700. So we're in the realms of a good humbucker, Gibson Les Paul. And so we get distortion there, so we have to turn it down even more. And at some point, we're going to lose the amplification. So that is the signal going in, and that is the signal coming out. So we're barely boosting. And so what we need to do is to create a signal, or what we need to do is the ability to change the amplitude, or sorry, change the power rails of the MXR, so you can get a lot more headroom and drive it with a bigger signal. So the first thing to do is to look at our power supply. Our power supply today is currently set at 9 volts. I've increased the power supply to 14 volts. Let's turn the pedal up again. And you can see now at max I've got 700 millivolts going in. I'm still clean. So the key is increase the rail voltages. And it's not as easy as you think, because one of the reasons that I use 14 volts instead of the 18 volts that we all use is there's a capacitor that provides some power supply filtering in the MXR, and that's rated at 16 volts, so I don't want to exceed that. So if we're going to increase the power supply, we need to probably remove that capacitor, replace it, or put in a new power supply, and those are all things that we're going to look at today. Alright, let's look at the schematic on the Electrosmash website. It's a fairly basic design. It's a single op amp. The gain is set by this resistor and this resistor, so 2.7 into 56 is about 25, so that's the gain. And then this pot here is going to increase this value, therefore reducing the gain. We've got coupling caps 0.1, and we've got a big 15 microfarad here. Not sure if that large value is necessary. On the output there's no volume. You have a small voltage divider network, 470 to 10k, which looks like most of the voltage that is on the end of C5 will appear across R10, so it doesn't do much there. And in fact, if I was going to do another mod, I'd probably replace this and this with a 500k or a 1 meg pot, but not for today, I don't think. Let's look at the power supply. So the power supply rails are plus 9 volts and ground, and then to make it work properly we have to bias the plus side of the op amp, i.e. let the guitar signal ride on a 4.5 volt signal, because you want it to be in the middle. So the signal coming in has got to be within plus or minus 4.5 volts, which is going to be pretty easy. And then here's the power supply section. So we've got a diode for reverse protection, and there's probably a voltage drop across that of 0.7, so technically I don't think that is 9 volts. And then we've got 2 resistors here, 200Ks that are the the voltage dividers to create the 4.5. And then here there is a cap, and that'll be for noise reduction. And you know, I think on the one that we've got here, there's another bigger cap here. So once we take it apart, I'll be able to verify that as well. But reasonably simple. So what we're going to do today is increase the power supply. Our challenge is to make 9 volts into a larger voltage. So to do that, you usually use a product called a boost or a charge pump. It's a DC to DC converter. I'm going to use the 1044. Why? Because that's the one that they use in the Klon to get the higher voltage rails. So it's tried and tested. Low noise. And we're going to leverage the schematic here in the datasheet. We're going to leverage 2 schematics actually. We're going to first of all leverage this one down here. Positive voltage multiplier. So on this one we put a volt in, and we get, we put 9 volts in this circuit here, and we'll get about 16.5 volts out. And it all depends on the voltage drop across these 2 resistors. And then also we're just going to add to it one more. Where is it? Negative voltage. Simple negative converter. So we're going to add this one to it as well. Make sure it operates like this. So we put 9 volts in, and we'll get something like minus 8 point something out. So we'll have 3 voltages on hand. 9 volts, 16 volts, 16.5 volts, and minus 8 volts. I built a circuit that does this. It's here. It's surface mount. I designed it and then set it out for fab. It's got a lot of capacitors on it. We do a lot of filtering, so it's very clean as it comes in. And then this is the chip itself here that does the multiplication. And we can get all the different voltages out here. 16.5, 9 volts, minus 8.6 volts by applying a 9 volt signal in. So this is what we're going to use, and I'm going to actually try and get the rails of the op-amp up to 24.5 volts with the MXR and see how it performs. So let's take apart our MXR microamp and inspect the PCB and see how close it is to the schematic that we're looking at. So we've got the PC board out. Everything is on a single board, which is good. Nicely done. It's made by Jim Dunlop, who his manufacturing company is in Benicia, which is very close to where I'm sat right now in San Francisco. They manufacture a lot up there, from picks to pedals. It's quite it's a legendary manufacturing site. We have a lot actually here in the Bay Area of different manufacturers. We've got Two-Rock, we've got Sun Amps, we've got EMG pickups, we've also got Mesa Boogie, probably more that I've ever forgot to mention. So it's quite the area in the Bay for guitar technology or music technology. So there's our op-amp, the single op-amp. Here are the caps that go around it that do the filtering, the frequency response filtering, I should say. Like, I know these 2 resistors here, they are the resistors for the 4.5 volt voltage drop, so that's the divider network. And then down here is the power supply section, and in a second I'll draw it out, and so we can look at it so we can understand what we want to do. And then this is a cap that wasn't on the ElectroSmash diagram, and this cap has a 16 volt rating, and that's why earlier I didn't do it more than 14 volts. So if we're going to put a higher power supply voltage onto here, we're going to have to remove or replace this cap. But first of all, let's draw out what this power supply section looks like. I'll take it straight from the board, and then we can decide how we want to integrate this guy, our voltage, our boost circuit. Traced out the power supply circuit now, and it looks like this. So we have 9 volts in, and then we have a reverse polarity protection diode. Then we have the switch for the LED. So I think this was either 2.9 or 3.9K. This is the foot switch, and then this is the LED. Then next up we have a filter network here. So we have 100 microfarads and 16 volts, and then we have a 100 ohm resistor. So this is going to get rid of any noise essentially that's coming in from the outside world. And I think what we're going to do is remove this 100 ohm resistor, and then have this part as the send and this part as the return. And I'm probably going to remove the capacitor or the diode, because I really want to get a hole for the ground wires as well. So I might end up removing both. We'll just see how it goes. And then we'll put 9 volts into the voltage converter. Where is it? There it is. We'll put 9 volts into the voltage converter, and we'll get out 16.5 on the other side, which is this hole here. So let's go and do that now. The boost circuit is hooked up. Here it is. And I also put a switch in, and so it's currently on the 16 volt, 16.5. So if I just flick it like that, we go back down to 9 volts, and you can see we've got severe clipping. We're still using our 700 millivolt peak-to-peak signal that we were using earlier, and I think it's pretty. We've got some more headroom, so that's good. One thing I do want to consider, though, maybe because we have a minus 8 volt terminal just here on the circuit, I might disconnect the ground pin of the IC and connect that to minus 8. So that should give me a voltage supply of 24 volts on the across the op amp. So let me just try that now. We've just completed some very delicate surgery. I had to lift pin 4 of the op amp, the 741, and I also lifted R8 and applied the minus 8.7 volts to that. And the result is I have a clean signal of 16 volts, which is pretty neat. So that's a very clean, high headroom boost circuit now that we have. So I think with that, I'm going to button it up, clean it all up. You can see there's a lot of wire everywhere as we've been going through this in a prototype phase. Verify it works, and then plug the guitar in and see what we get. Got it reassembled, tidied up all the wires. You can see I've put the board where the battery would go. Looks neat. And I've got 16.5 volts peak to peak, perfect sine wave with 700 millivolts of peak to peak coming in, so not bad. And I think we've got the gain set to about 90%. Yeah, so as soon as we get about 90%, we can see a clip on the top, so that's probably due to the tolerance of the voltage divider resistors, and then it clips a little more evenly. So once you get in the high end, you know, the top 10% of the pot turn becomes an asymmetrical clipper, which we'll try and avoid, I think, because there's so much voltage here going into the tube. I think it's going to create some natural distortion that doesn't have a clip on it, and so we're not sending a clip into a clip circuit, if you will. We're sending a pure signal into a circuit that will be overdriven and clip on its own accord. So that's great. Very pleased with that. And so let's plug the guitar in now. We've got the guitar plugged in to the pedal, and we can see it on the scope. So if I strum it hard, we're not seeing any clipping. Move it on to the bridge pickup. I got P90s on this. I'm seeing it peaking at about 7 volts in places. Of course, the response time of the scope's not that good. But it was a much different story before I actually did this high voltage mod to the circuit. Alright, let's plug it in to an orange amp. You can probably see it in the corner just behind the DMM You can see a bit of orange, and I've got that on the clean channel, and so that hopefully will get clean on clean and just give it a bit of an edge. So let's try it out. Pedal off. Pedal on. That's wonderfully harmonically rich. Putting quite a large signal. Let's crank it up a little bit. Now that's very harmonically rich, but still a clean signal. So we're not prematurely overdriving the signal or clipping the signal. We're putting a pure amplified signal with lots of headroom into the first stage of a tube amp, the orange tube amp. And those harmonics you can hear are generated by the first stage being overdriven by our super clean preamp pedal. And now, just for fun, let's switch to the bridge pickup and put the JCM 800 on. I bet we could even bring the gain down a little bit and still have that level of distortion. Sounds amazing. Love the headroom. And because we're not sending a clip signal full of harmonics into another stage that's generating even more harmonics, it gets really, really messy. So putting something clean into a high gain amp feels really good. Well, thank you for sticking with me through the video. Don't forget to like and subscribe. I'll put the power supply board on Reverb if you're interested in getting one for yourself to modify your own pedals. And also, contact me if you want a pedal modifying for higher headroom. I think we can look at any pedal within reason, obviously. It's got to be analog, and I think we can do surface mount, but I'd prefer to have the through holes of the older pedals. And I'll see you in the next video.